Let's take a look at the Labyrinth problem. This problem provides a jar package to the contestants, which is equivalent to a white box audit challenge. It is written using the Spring Boot framework with only one root and one model. This root is deserialized, which performs Hessian deserialization. The principle of Hessian deserialization will not be explained in detail. Its most important characteristic is that Hessian has multiple versions. In this problem, the Dubbo RPC component is used. Dubbo is a widely used framework developed by Apache, which utilizes many middleware components. Dubbo supports multiple transmission protocols, including the Hessian protocol. Different versions of Hessian have different uses. The biggest advantage of Hessian deserialization is that it can deserialize interfaces that do not inherit from serializability. In native deserialization, all classes must inherit the serializable interface. However, in Hessian, inheritance is not required serialization, and deserialization can still be performed. Here, I have turned on the switch. It is closed by default. But some middleware can disregard classes that do not implement serializable even without explicitly enabling it. One of the biggest characteristics of Hessian is that it has a long blacklist. Here, almost all classes with known exploitation points, such as those in YSO or Java Chain, are basically blocked cleanly. A direct breakthrough is very difficult. Moreover, this problem only has Spring Boot's built-in dependencies and JDK dependencies, making gadget chain mining highly challenging. I have provided a gadget class, which is a proxy class. The reason for writing this proxy class is that in Hessian's deserialization, logic proxy classes cannot be successfully deserialized unless in the same JVM virtual machine, because proxy classes generate a temporary class. When the remote server cannot load this class, it will directly report an error. Observing Hessian's source code logic, it does not have special handling for proxy classes. Directly loads the class name via class for name, throwing an exception if not found. Therefore, there must be an intermediate class that inherits from the proxy. The actual inherited classes are very few, so I customized one. It contains a comparative method. This comparative method is frequently called in TreeMap, making it relatively easy to trigger. Comparative receives an object parameter. Oh, this class can store a method object, but there is a conditional check. It must be the comparative method, otherwise an exception is thrown. If it is, then look for invocation handler. Interfaces invoke method for invocation, which is dynamic proxy. There are many classes that implement the invocation handler interface. We can focus on these classes. Some classes have reflective calls. I initially performed mining on the source code side with tracing. Then found this class. Its method is very special. It can store a method and then pass the proxy and parameters during invoke. In other words, this class is equivalent to being able to execute. It can be understood as executing any method of any class. The parameters may not be very controllable, but that doesn't matter as long as we can achieve calling any method of any class through reflection. The harm is significant enough. Many class methods do not require parameters, such as runtime get runtime. Exec. These methods do not require parameters, but the runtime class is clearly on Hessian's blacklist. There are many runtime methods. Although they require parameters if they are of string type, they should also be passable. However, this class is on the blacklist. We need to find dangerous methods. Back to this class. Let's look at this DraceProbe class again. It inherits from the probe skeleton class. We need to find a subclass that inherits the invocation handler interface and can call the target method. Through mining, we found it. Let's take a look. We can run it with tabby syntax and find an obvious call chain. This provider skeleton class This class inherits invocation handler, its invoke method. In this method, executes var4 and then performs a judgment. It first checks the incoming parameter var4. If it is not equal to a certain value, it jumps. This is easy to bypass, and the class corresponding to var4 should also be controllable. var_was get declaring class obtains its inherited class. If it is not the specified type, Then it enters this series of logic var2 and then calls invoke. If so, it enters the trigger probe logic, checks the method, and then calls var3, var2, and var3 are also controllable and can be set as our final sync point. This provider Skenoton class we can pass it as this dtrace probe class. The entire chain starts from Hessian goes through dynamic proxy. This proxy class is the custom proxy class we saw. Then to this probescalation class, because this class is an abstract class. The class implementing invocation handler is an abstract class, so we still need to find its subclass. The subclass of this probescalation class is relatively easy to call. It inherits from the parent class but has no additional methods. Find this class for serialization. Because it is an abstract class, the parent class method will be executed when called. It directly finds that interface this logic is correct. What is actually serialized is this null provider class, then find probe, and after calling sequentially, achieve arbitrary code execution. Since templates info is on the blacklist and cannot be called, we can find similar EL expressions and inject a Godzilla shell via the JavaScript engine. The overall logic is roughly like this, and we can complete the problem. In fact, there are many classes that implement invocation handler, not necessarily the only solution. You can also check Spring Boot dependencies. The focus is to run the chain with static analysis tools looking for key methods such as invoke, get runtime, etc. These can all be tried because Hessian does not require implementing serializable. The attack surface is larger than native deserialization. There may be unexplored call points in JDK or Spring Boot dependencies. That's the general logic of this problem.